Hello guys. Today we are going to learn a session about Taylor series. What does Taylor series means? Taylor series is something we can use Taylor series for any functions. It is something we use for approximation. Even in the calculators, something you want to find like sine 1 radian or square root of e. So such things we need some approximation. Since these are irrational numbers, we need some approximation to a certain level so that we can have a brief idea about the functions. So for that reason, we use Taylor series. In Taylor series, before learning about Taylor series, we have to get an idea what the Taylor series is. For that purpose, I have written here the mean value theorem. Mean value theorem is something says a function f is continuous on a closed interval a comma b, and it's also differentiable on the open interval a comma b. There is a constant, there is a c in between a and b such that f dash c, the derivative of c, is equals to the fb minus fb over b minus a. We can explain like this. We can draw graph which a and b. Say the function goes like this. So the right hand side of this is fb minus fa over b minus a is actually the gradient of the straight line joining the endpoints. This is the gradient. What does mean value theorem says is there is a point in between a and b such that the tangent drawn in that point should be parallel to that gradient. So we can find such a point here so that these things will be parallel. So that is the mean value theorem actually. And then if we move on using the application of the mean value theorem, we can say for a simple function f, and say it's actually is a mean value theorem 2, and fx equals, when we cross multiply these things, we can get fx equals fa plus x minus a into f dash zeta. It means that there is a zeta in between the range a and b, so that we can find fx. Actually, this is the basic part of Taylor series. Taylor series, we can write the Taylor series, the basic definition of the Taylor series. Fx equals fa equals fa plus f dash a into x minus a over 1 factorial plus f double dash a into x minus a squared over 2 factorial, and it goes on. This is the actual Taylor series. For this purpose, fx should be infinitely many times differentiable. If not, we cannot find f double. Fx should be infinitely many times differentiable. So this is the basic Taylor series, but in this semester we are not going to use this basic, but we are upgrading this Taylor series into a series format. So let's write what Taylor series we are going to study. So actually any function which is n plus 1 times differentiable. N plus 1 times differentiable on the interval a comma b, on the closed interval a comma b, can be written in the form, and that is called the Taylor series. So that form is given here. It means that fx is the summation of this part and plus this part. So we'll see later what this part and this part means. This is actually, there is the extended version of mean value theorem, that there is a zeta such that this is what we know, like here fa, and this is something what we don't know, that zeta part. So we are saying that the summation of k equals 0. Here the summation of k equals 0 tends to n if k differentiated a and x minus a to the power k over k factorial plus this part. So we are writing that this part is a polynomial. It's kth power of kth degree polynomial of x actually, and then this is n plus 1th degree polynomial of x. So these two are polynomial. We are writing this is the Taylor polynomial actually. What I say, the Taylor polynomial is this one, and the remainder is this. So actually, in Taylor series, when we are going to find something, say square root of e to the power 0.5, we cannot find the absolute value of this. So there will be some, and up to a certain extent we can approximate. So we can find up to which extent we can approximate this e part. So this reminder will say that up to which extent we can approximate this function. So let's go on with Taylor series. Say okay, this reminder is actually what I wrote here. There is a zeta fn plus 1 differentiated zeta x minus a to the power n plus 1 and n plus 1 factor. Actually, this reminder can be written in another format, that is the integral format. This format is something we got from the integral format. The integral format I have given here. Actually, I write there. Rn x comma a equals 1 over n factorial a to x f n plus 1 t to x minus t. This is the remainder. So if we are need to find something, as I said, e to the power square root of e to e, we will be approximating up to a certain extent, and that certain extent will be given as these reminders.